Now we will talk about the electric field. Look at the charges, positive charge or negative charge. There is a region of space around the charge in which the effect of a charge appear. As you studied in the previous year about the magnet, and we said there is a region around the magnet in which the effect of magnet appear. The charges like magnet. There is a region around it in which the effect of a charge will appear. Okay? This region of space called electric field. So what is the meaning of electric field? It's a region of space surrounding an electric charge in which its effect appears. Okay? And this region represented by lines. We represented it by lines. We represent it by lines. Okay? These lines called electric field lines. So what is the meaning of electric field lines? They are imaginary line. We cannot see it. That's not found in the real. But we use it to represent the electric field. Okay? That show the path taken by small free moving positive charge placed in the electric field. Okay? So the electric field represented by lines. This line called electric field line, and they are imaginary line. Okay, look at the shape of electric line of the electric charges. Firstly, positive charge. Look at this. Around the positive charge, there are arrows that go out. Okay, go out. That mean what? That mean electric field start from positive. Okay, start from positive. And if you look at negative charge, the electric field line go to in the charge. Okay, the direction of arrow. Okay, look at this. In negative charge, go to enter the negative charge. Electric field enter negative charge, but go from what? From positive charge. That means electric field start from positive and end in negative. Okay, we'll ask you draw the electric field lines. So we will draw it like this. If ask you draw the electric field lines of positive charge, you will draw positive charge and the electric field line go out from it. Okay, and may ask you draw the negative charge with its electric field line. You will draw it, but the direction of arrow go to in. Okay, number 2, if you have two charges, if you have positive and negative, the electric field line will move to what, or start from what? From positive to negative, and the other arrow of negative go to in, and the other arrow of positive go to out. Okay, and if we have same charges like negative and negative, we said same charges repel each other, so the electric field line repel each other. Okay, not intersect to each other. Okay, and if you have charge and plate like this, positive charge and negative plate, the electric field will start from positive and end in negative plate. And if we have two plates, one of them positive and the other negative, the electric field line will start from positive to negative. You will draw it like this. We have negative plate and positive plate, and the electric field line transfer from positive to negative. Okay, and if you have charge and plate, positive plate negative, the line will move from positive to negative, okay? And the other line go out. So you will keep the direction of arrows, okay? So what is the properties of electric force line? We said number one, they are imaginary line, not found in the real, okay? And they don't intersect each other. Like if we have the same charge and they repel each other, not intersect. This is wrong. Look at this. This is wrong. Not intersect each other, but move away from each other, okay? Number two, we said the electric field starts from positive to negative. So we will make arrow from positive to negative. Number three, the electric field and at the surface of a charged metal object and don't penetrate them. Okay, that means electric field not pass through a charged metal object surface. Okay, but end on it, not penetrate it, not pass through it. Okay. Now we will talk about this device that's called electroscope device. Firstly, this device consists of what? Consists of copper disc, okay, and copper root and golden leaves, two leaves made of gold, and glass container, okay. So what is the importance of this device? We use it to know if the object charged or no, okay. We have object, tested object. We will put it on this device to know this object charged or not charged. It is the first use of it. The second use, determine the type of this charge. If the object are charged, we will determine the type of this charge that's found on it. Okay? The first use, as we said, to detect the electric state of an object, to know if it's charged or no. Firstly, we will touch the metal disc of electroscope with your hand to ensure it's not charged by any electric charges. Okay, how we will know there's no charges on the device? The golden leaves will be close to each other, attract each other. That means there's no charges found on the device. Okay? Then the second step, we will bring the object to be tested and put it on the copper disc. Okay? If the leaves of electroscope don't diverge, don't spread out, that mean what? That means there is no charges found on the device and the object. So that means the tested object is not charged. Okay? But look at this. When we put the object, what happened to leaves, golden leaves? They diverge. That mean what? That mean the object are charged. So this is charges transfer through the copper and put on the leaves, so the leaves diverge. Okay. So the first use of this device to know if the object is charged or no. This type of a charge called charging by contact that cause electroscope disc and the two leaves to acquire the same type of a charge as the root. When we put the object, in this case, when we put the object, the leaves diverge. That means what? The charge transfer from object to the leaves. Okay? This type of charging called charging by contact. When the object touches the copper root, the leaves acquire the same charge of the root. So this is the second type of charging of object. Charging by contact. The process of a charging an uncharged object by its contact with charged object. If we have two objects, one of them is charged and the other uncharged, when touch each other, the uncharged object become charged. Okay? And the second use of this device, determining the type of a charge on a charged object. Firstly, we will charge the electroscope with certain electric charge, for example, positive. Okay? So look at this. So the leaves will diverge, okay, because it's charged. And we will bring the tested object and put it on the copper disc. Okay. If you look at the leaves in this case, you will find the divergence or repulsion increase between them. Increase. That means what? That means object has the same charge of electroscope device. And we said electroscope has a positive charge, so that means the object has positive charge also, because the same charge repel each other. Okay, so the divergence between leaves increase. And in second case, we will put the tested object and we will notice the divergence between the leaves will decrease. That mean what? That mean the object have different charge, so the attraction occur between them and the divergence decrease. Okay, that means the charge of a object is what? Is negative, because the device is positive, and the divergence decrease. That means object have opposite charge of device, so the object will has negative charge. Okay, so when divergence increase, that means object have the same charge of device. When divergence decrease, that means the object have different charge of the object, the device. And the third use of the electroscope device, comparing the magnitude of the charges on different charged objects. Okay, in charging by contact, the charged object touch the object to be charged without wrapping. There is no wrapping occur, but touch each other only. Okay, and the object to be charged acquire the same type of a charge as the touching object. Okay, takes the same type of a charge of touching object. Number two, attraction can occur between uncharged object and a charged object, as the case of paper scraps being attracted to comb after being rubbed. When you brush your hair, this friction occurs between your hair and the comb, so the comb acquire or get electrons that accumulate on its surface. So when we bring the comb near to paper scraps, it will attract them. And after some moments, the paper scraps will fall or go away or repel from the comb. Why? Because the paper will take the same charge of the comb. Okay? So there's repulsion occur between them and the paper pieces will fall. Okay? Life applications. Number one, fuel transport vehicles have metal chain that dangle to touch the ground. Look at this. In the vehicles that transfer fuel, there is a metal chain. Okay, why? What is the importance of this chain? As you know, this vehicle has a tank that contains fuel, and when it go, make a friction with the tank. Okay, so what happened? Some charges accumulate on the surface. Some charges produced due to friction between fuel and the tank. Okay, when these charges accumulate and accumulate, what happened? the fuel composition will occur. So the chain found in this vehicle to discharges that produced due to friction. It will take it to the ground, okay? So that prevent the fuel composition. Now look at this. To discharge the electric charges generated by friction between fuel with the surface of fuel tank to prevent the fuel composition, okay? Number 2, lightning rod. It's a composition. Metal rod. It's a metal rod. The lower end fixed in a plate poured in the ground. Okay, look at this. Rod. The lower poured in the ground, fixed to metal poured in the ground, and the upper part pointed, allowing accumulated electric charges from nearby clouds discharge to what? Or pass through it to the ground without causing any damage of building. Look at this. There is spines, okay, that take charges from the clouds, okay, pass through it until go to ground, okay. So it prevent the damage of building. Its importance: a system used to protect the structure of buildings from lightning strikes. Give reason: separation or divergence between the gold leaves of positively charged electroscope. The electroscope is positive, okay? Decrease when an ebonite rod wrapped with wool is brought close the electroscope disc. We have electroscope disc has a positive charge, and ebonite wrapped with a wool, so it will have what? It will have negative charge, okay? So what happened when we put ebonite on the copper disc of this device? The device has positive and ebonite has negative. The divergence between leaves will decrease. We said different or opposite charge, the divergence will decrease. So the answer: because the ebonite rod acquire negative charge when wrapped with wool, and thus the divergence of gold leaves decrease due to what? The difference in the charge between the rod and leaves, okay? Question number 2, what happens to paper scraps a few moments after they are attracted to the comb? Explain. We said when you brush your hair, the comb friction with the dry hair give it an electric charge that cause attraction of paper scraps. And after some moments, these paper scraps will move away from the comb because what? Because the contact between comb and paper scraps give the paper scraps same charge of comb, okay? So they both will have same charge after some moment. So what happens if there is a same charge? It will repel, okay? Causing repulsion between them, which make them to fall.